Do an introduction video about polynomials, and this is what we're going to be studying for the next couple weeks. With a polynomial, you have the standard form of a polynomial function where you write your highest degree first down to the lowest, and n, or your exponent, cannot be negative. So here they give you p of x. P of x means it's a function. Therefore, you have a cubic term, which is anything to the third power, quadratic term, anything to the second power, linear term is your variable to the first power, and constant, there is no variable next to the constant. That's why it's a constant. So the degree of a polynomial, it's your highest exponent for a term with non-zero coefficient and a polynomial expression in standard form. So you can have an example. I can have p of x, it's a polynomial function of 3x to the fourth plus 5x plus 3. It's standard form because it's from highest degree to lowest. My degree is 4 because that is the highest exponent that you see. You can have f of x equals 9x to the fourth plus 2x squared plus x. Standard form, highest exponent down to lowest exponent. Your degree is 4. Again, do not add up your exponents to get the degree. The degree is the highest exponent that you see in all terms. You can classify a polynomial by its degree or by its number of terms. So here's a little chart where if you have 0 degree, it's a constant. There's a polynomial example, just 5, and it's one term. If you have one term, it's called a monomial. It's still a polynomial, but it's more specifically called a monomial. Then you have anything with degree 3 is called a cubic. Why? Because your highest exponent that you see is a 3, so in 4x to the third minus 2x squared plus x, that's a cubic because your degree is 3, number of terms is 3, which is a trinomial. You have to remember that the number of degrees does not have to match the number of terms. So here are some problems that you might see writing the polynomials in standard form. So you have to go from highest degree to lowest. So 9x squared plus 3x plus 5. Next, you have to look for the highest degree, which is 4. So you're going to write from 5x to the fourth plus 3x to the third minus x. Next, we have to combine like terms and also write from highest degree to lowest. We know that we have x to the fourth, so that's the highest. We have 10x squared minus 6x squared gives us positive 4x squared plus 4x minus 12. Next, we have negative 4x to the fifth plus 2x squared, and then positive 3 plus 10 is plus 13. Now we have to classify it by degree, degree 2, and it's a trinomial. Degree 2 is called a quadratic. So here we have a degree 4, 3 terms, it's a, again, trinomial. Next we have a degree 4 with 4-term polynomial. Next we have degree 5 with 3 terms. So it's a trinomial. Next, you can have the end behavior be determined by the a coefficient and the degree of the polynomial. I'll give you a minute to look at this slide before we move on. Notice that end behaviors can only be up, up, down, 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 up, or up, down. To determine the end behaviors, you're going to have to look at the A coefficient and your N, which is your degree. So if your A is positive and your degree is even, it's up, up. A positive and odd, down, up. A negative, down, down. A negative and degree odd, it's up, down. Here are some examples. So here's our A. 3 is our N. Looking at the table, A is positive, N is odd. So A is positive, N is odd. We say that the end behavior is down, up. Looking at the second one, again, you have to look for the highest degree. Highest degree is 4, so that's N. Our A is negative 2, so our A is negative. Our N is even, so A negative, even, it's down, down for the end behavior. Polynomials, you can also determine how many times it will turn, and the polynomial will turn at most one less than the degree. So here are 4 examples. If you have a straight linear line, you're going to have a degree 1 because it's x to the first, no turning points. If you have an x squared, you're going to have 1 turning point. If you have degree 3, you're going to either have 0 or 2 turning points. So again, the number of turning points is determined by number of degree minus 1. So again, your turns is going to equal degree minus 1. So here we have to describe the graph. Our end behavior is, again, A is negative, N is odd, so we know it's going to be up, down, end behavior. And turns, so number of turns is degrees minus 1, so we're either going to have 2 or 0 turns. I'll let you do B by yourself. Last part is determining what type of polynomial you have and its degree by a table of values. So here you want to find the difference of the y values until you get a constant number. The number of differences it takes to get to that constant is the degree of the polynomial. So to get to the degree, you subtract negative 7 minus negative 1. So negative 7 minus negative 1 is going to be negative 6. Subtract negative 3 minus negative 7 will give us 4. Subtract bottom minus top. 5 minus will give us 8. Subtract again. 11 minus 5 is going to be 6. Subtract 9 minus 11 is negative 2. Subtract and we get negative 16. Subtract again. 4 minus will give us 10. Will give us 4. Will give us negative 2. Will give us negative 8. And here we get negative 14. Subtract again, we get 6. Subtract again, we get 6. 6. And subtract, we get 6. So again, all I did was subtract the bottom from the top, and we're looking for a constant. So this is the first difference the second difference, and the third difference. So how many differences does it take to get a constant? It took 3. Therefore, this is a third degree polynomial. Don't worry about finding the actual function that models this. Here we just want to know how many degrees it is. That is it for the introduction to polynomials. If you have any questions, please see me